Welcome back to Spacetime. Have you ever wanted to sail the seas of intergalactic space? Well, you're in luck. Today's topic is light sails, what they are, and how we can use them to travel through space.
Everybody get up, it's time to slam now. We got the real jam going down. Welcome to the Space Jam. Here's your chance, do your dance at the Space Jam. Alright.
Today's sponsors are books. It's like individual screens with words on them. And coloring books, when words are just too hard. Last video, we talked about propelling a spaceship using nuclear bombs. Today, we're going to talk about propelling a spacecraft using light sails, also known as solar sails. This design is much more realistic than our last form of transportation, so realistic that we have already used it multiple times. Boat sails capture the force of wind, light sails capture the force of light. Light is made up of particles called photons. Each photon has an extremely small amount of pressure when they come in contact with an object. If we harness a huge amount of photons from a star or a laser, then we should be able to propel a ship through space using that pressure. Quick history lesson. Johannes Kepler, who is most known for his laws of planetary motion, was the first scientist to hypothesize that photon pressure, or light pressure, existed. His hypothesis, in 1619, was based on his observations of comets. A comet is any small solar orbiting body made of ice crystals, dust, and rock. He noticed that all comets have tails and that the tails pointed away from the sun. He then developed the idea that since the tails are always pointing away from the sun, that there must be a great pressure from sunlight causing the dust and ice crystals to be blown off the comet. His hypothesis was proven correct by James Maxwell in 1873, who proved that photons have an electromagnetic momentum. Unfortunately, we still have not created technology to accurately measure the momentum and thus the pressure from a single photon because the value is way too small for any instrument to read.
Can we use this momentum and pressure to move a spacecraft?
Great question, Squirt. Yes, we can. We have actually already accomplished it multiple times. I would like to discuss 3 examples of light sails, 2 that have already proven to be functional, and 1 new exciting idea. The only successful light sail to get past Earth's orbit has been the Icaro satellite, built by Japanese scientists in 2010. It had a 40 by 46 foot sail and reached Venus in 6 months. Icaro stands for Interplanetary Kitecraft Accelerated by Radiation of the Sun. It was actually able to be steered for a short time. The scientists could activate liquid crystal panels located at the edges of the sail. The crystals could manipulate the reflectivity of the sail and cause that portion to have more or less light pressure in that area of the sail, allowing its movement to be controlled. Another successful light sail has occurred more recently. The Planetary Society, whose CEO is Bill Nye and is a publicly funded group with more than 60,000 members in 100 countries, were able to launch a light sail of their own on June 25, 2019. It is currently still in orbit around Earth as we speak. It is the first spacecraft to orbit Earth solely by sunlight. Let's look at an animation of this solar sail satellite. The last light sail craft is one that is still in development. Breakthrough Starshot is a $100 million research and engineering program created by Yuri and Julia Milner, aimed at developing new technology to reach new speeds for unmanned spaceflight. The research team's goal is to have a spacecraft that can reach speeds of about 20% the speed of light, or 100 million miles per hour. If they achieve this speed, we could have an unmanned spacecraft reach Proxima Centauri b, remember which is the closest exoplanet, in about 20 years. How will they accomplish this? Nanotechnology. Nanotechnology is a huge part of this research initiative. The smaller and lighter the materials, the faster the spacecraft. Any light sail needs three things. It needs the sail for movement, it needs a way to collect data, and it needs a propulsion system. For Breakthrough Starshot, the data collector is called the Star Chip. This is a gram-scaled wafer that can carry cameras, photon thrusters, power supplies, navigation, and communication equipment. They are also creating a light sail that will use metamaterials that can make meter-scale sails no more than a few hundred atoms thick, weighing only a few grams. To put this in perspective, a piece of paper is roughly 400,000 atoms thick. The last technology that is new is the source of light pressure that will push the sail. Instead of using light from the sun for propulsion, the Starshot will use a man-made array of lasers. Let's watch an animation of Breakthrough Starshot.
Frickin' laser beams!
It seems like this could be the way of the future for space research.
Oh, hey Mark, what are you doing here? Ollie had a juggling accident? Is he going to be okay? Phew, thank goodness. Mark said Ollie's going to be okay. So what are you doing here? Oh, my references. Thanks for the reminder. You're the man. I mean, you're the shark. My references today are The Future of Humanity by Michio Kaku, the Planetary Society, and the Breakthrough Initiative. Thank you for letting me use your information and your animations to help talk about light and solar sails. If you'd like to know more about the Planetary Society, it's a great way to get involved with the scientific community. You can research them on Google and go through their website on your own. Remember, at the end of the video is going to be the slides with the goals for today. Don't forget to check those out. Also, don't forget that you can email me with any of your questions. A couple people have already with great questions. I try and email back as quick as possible. And keep working on your presentations. Good luck. Thanks, Mark.